Okay, section 27 of the homework. All right, so homework in section 27. We'll go through the problems. We'll go through them one at a time. Certainly, as I'm doing the problems, I want to encourage you to think about what's being asked of you and to see if you can do that based on the material that we're presenting in class and through the examples. All right, so we'll go through all the questions. What's the problem for a lot of students here? These are more involved problems and they take more time to get through. All right, if you're weak in algebra and trig though, these problems can do to be incredibly difficult. All right. And that's what we're saying. You really need a prerequisite skills to get through these problems over here. All right. So I'm going to switch over to the whiteboard. I do want to emphasize that we do give you high quality images that may help you somewhat in learning the material. All right. So let me switch over to the whiteboard and one moment to do so. And I think we're there. So let me read this to you. And it certainly, we're doing the homework now. And this says, you're given a figure 119 on page 389. That's the very next page, by the way. It says the graph of f of x. It says find the point or the points where the second order change is signed from negative to positive. So the second derivative needs to change from negative to positive. And we're talking about the second derivative. Now, what is this communicating? Concavity. So a negative concavity would be something where it's concave down, and a positive would be where it's concave up. So we're looking for the point where it changes. So I'm looking around the curve. I'm looking for where it's concave down and then goes to concave up. So I'm going to say over here, and looking at it, I'm going to say concave down. That's good. And then it goes concave up. Okay. Well, I think I found it. And what is it? I'm gonna outline the point for you. It's right here. All right. Now I got to be honest with you. The graph is not the best. I kind of stole this graph from a book, and it's a book that we are, at least we were using. We used it for years, and someone said, "Oh, let's stop using the book." Not sure why, but I want to claim to you over here is that, and again, if this happens on the exam, we'll be clear about it. This is A, this is B, this is C, this is D, this is E, this is F, and this is G. I wish they were better lined up for you. So what's the point? It's at D. All right, let's go back to the answer key and make sure they said it's D, and they did say it's D. All right, so that's good. Let's go to the next one. Next one, given the graph, and the graph is given to us. I don't know if I need the graph, but it says given the graph. Well, you know what? Maybe I do need the graph. But before I do that, I want to point out, I don't think I really need a graph. All right, what I need is, given the graph, the indicated transition points. Well, someone says, what are transition points? We tell you local min, local max, and inflection point. So what I want to do is, I'll look at the graph, but right now I want to go through the work. And what's the work going to be? Well, I need to write down, y equals, well, I got that. I don't need to put that down again, but I need to do y prime. What's that going to be? 3x squared minus 12x plus 17. Boy, that's nasty looking, isn't it? So what do you get over here? And I'm looking at it, and I'll come back to that later. Let's look at the second derivative. And what's that going to be? 3, not 3, it's going to be 6, right? 6x minus 12. Well, to be honest with you, this one's easier for me to deal with. And certainly we'll look at the graph later, but what do I mean by that? I can look at the second derivative now. Where does it become 0? It looks like at 2, right? And to the right of 2, it's concave up. I'll put that down. And to the left of 2, it's concave down. We'll look at the picture later. I want to look at this one over here because it's kind of disturbing me. It looks so difficult. And this is going to be y prime. So I'm going to say, I don't think I can do that with my fingers. So I'm going to look at the quadratic formula. When does it become 0? So let's do that. So I'm going to say, when does 3x squared minus 12x plus 17 equals 0? Well, I don't think I can use my fingers to do that. So I'm going to use the quadratic formula, and it's going to be x equals, oh, it's going to be a tough one. So the bottom's going to be twice a, which is 6, minus b, which is 12, plus or minus, well, the b squared is 144, minus 4 times 3 times 17. But what I know about this over here, that this is complex. How do I know that? I'm looking at the discriminant. And without me doing an arithmetic, it's 12 times 17, which is clearly bigger than 144. So 144 minus a number bigger than 144 is definitely negative, so it's complex. So then the question goes is, This is either always going to be positive or always going to be negative. Well, let's take a look at it. Well, if I took a test point, any test point at all on the number line, like 0, what do you get? It's positive. So what do I know about this thing? This function is always increasing. Right, let's look at the graph. And I think I'm looking for a graph that's always increasing and has a point of inflection at 2, f of 2. We'll go to the key later. Let's look at the graph though. So I'm seeing it, and I want to point out what I'm seeing. I'm seeing a curve, as we said, is always increasing and has a point of inflection at 2. And what I say, concave down to concave up. That seems to be reasonable. Let's go back. I'm sure you remember me talking about that. And let's put the answer down then. So what are the only point I'm going to list down? There's only one point to put down, and it's got a point of inflection. And what's the point of inflection? It occurs at 2. All right. The work is down over here. No local extreme, by the way, inflection point. All right, let's do this one over here. And again, they give me the graph. Thank God it's on the interval between 0 and pi because it's a lot easier for me to deal with. But I'm going to go through the work, and I'll look at the graph later. And what's the work going to be? Well, f prime. Wow, I'm calling this f of x now. What's that going to be? Well, that's going to be 1/2 minus sine x. And then I'm going to do f double prime. We'll look at the picture later. And that would be what? That would be minus cosine of x. And by the way, my analysis is only going to take place between 0 and pi. And this is for the first derivative. And the second derivative is only going to take place between 0 and pi again. Well, the second one's really easy to do. What is a cosine function 0 between 0 and pi? That's at pi over 2. That's pretty simple. It's 0 there. I put a circle on it. Now, if I did a number between 0 and pi over 2, like pi over 4, it's going to be negative. That's not so bad. What does that mean? Concave down. If I took a point between pi over 2 and pi and plugged it in, like, you take a point like, let's see, 3 pi over 4, that'd be positive now. That's not so bad. Again, you need trigonometry to know that. So I know there's a point of inflection. Look at the graph later. The point of inflection is going to be at pi over 2, and then f of pi over 2. All right, let's talk about the extreme, if there's any. And I'm looking, when does the sine function, I'm looking at this, by the way, when does the sine function become equal to 1/2? Well, again, I'm back in my, pre-calc days to do that. And let me get my eraser out. Sorry about that. Oops. I'm going to do my little reference triangle, 1, 2, and this would be √3. So what's that angle over there? It's 30 degrees. 30 degrees. All right. Now, by the way, there's another angle. I'm thinking the wheels on the bus go round and round in trigonometry. So one would be 30. That's in the first quadrant, and 30 is pi over 6. All right. And then I'd have to do another one, and that's in the third quadrant, and that would have a rest of 30, so it'd be 150, right? And I'm going to convert that. And what's that going to be? That's going to be 5 pi over 6. And that's over here somewhere. And so we say, could I just use the picture now to do it? I'm not opposed to it. Not at all. Not opposed. So I'm going to say that this is 30 degrees, just for the students, myself included, that have tough time with radian measuring. Let's see if we can do it. And I'm going to do between 0 and pi over 6. And I'm wondering what kind of number do I get? And certainly someone says, well, that's really tough for me to even think about. But I hope you realize that if I'm below pi over 6, the sign would be below 1/2. So this would be positive. Now, what does that mean? It's increasing. Now, once I go beyond pi over 6, beyond 30, it's going to increase above 1/2. So this would be negative here. Again, if you want to take another number, like, pi over 2, Certainly between those two numbers, you could do that. Now, someone says, well, what happens after pi over 6? Well, if you thought about it, after pi over 6, right, it's going to get smaller than a half now. So it's going to be back to positive again. All right, that's tough. For a lot of students, really tough. I mean, especially if you haven't put a lot of time and effort into your pre-calc studies, this is another brick in the foundation that's preventing you from building a structure above it. All right, and mistakes happen, by the way. So I'm going to say point of inflection, I have a relative max at the point pi over 6, comma, f pi over 6. And a relative minimum at 5 pi over 6, comma, f 5 pi over 6. All right, let's take a look at our K. See how we done? Well, I have to go to the next page, right? I'm going to have to grab it. Oh, there's the picture. And I'll look at the picture later. I'll look at the answers. I'll grab it. And I'll copy this. I'll paste it here. Give me a second to do so. I'm also going to grab the picture. I'm going to paste that right here. And I know it's tough. I really do know that. And I'm going to encourage you that this, if you're looking, to do well in the class, you're going to spend a lot of time thinking. All right. So let's take a look. Let's see if I've done what I was expected to have done. All right. Now, did I get the derivative down correctly? Yeah, I think I did okay. Did I get the second derivative correctly? Yeah, I think I did okay. All right. Local maximum pi over 6. Did I write that down? Yep, I put that down. Local minimum 5 pi over 6. I got that down too. Okay, inflection point at pi over 2. Yep. Let's go to the picture, and I want to put these down for you. So again, I'm looking at the picture. I'm not saying it's my ability to draw pictures this good is I really can't, but I hope you can agree in this region over here, it's concave down. Then there's a point over here. What's that point? It's this point right here. And then what's do? It goes concave up. Did we say that? Concave down, concave up. All right. What do we say the relative maximum was at? We said it was over here. All right. That's right there. What do we say the relative minimum was at? 5 pi over 6, right over here. Again, for students that need to write them down as decimals, that's fine too. But don't do that on exams, by the way. Just for your own edification, you might put the decimals down and realize where those numbers are approximately along the number line. All right. But so far, the graphs have been somewhat helpful if you're studying. Right now, if you're not looking at those graphs, you're just saying, like almost like looking at a bad magazine, you're just passing over the images, you're not learning much. It takes a tremendous effort to learn. And that's an effort that you put in, not what we do, it's what you do. All right, let's keep going. Got this page covered out. And let's do this one over here. I like this one over here. I'll be honest with you, they just want me to indicate the transition points. And I want to point out, sometimes on exams, people do the weirdest things, by the way. And by the way, we're not trying to tell you or offend anyone. We're just simply saying that this is really inappropriate behavior. But they'll say, oh, and they'll actually say, oh, that's a relative maximum. They'll say relative minimum over there. They might say there's a point of inflection somewhere. They can't really get it, but they look at it. Maybe they say a point of inflection here. Another one, let me say concave down, maybe over there, maybe over here. You get the idea. They say, oh, they're the transition points. In other words, they have some idea that something's there, but they don't know what it is. Right. So what I'm going to go, I'll go through the work that's required to get those points. Right. So this could get tough, and I'll go through the work to get those points. All right. So and then I'll describe the points, and I'll put the points down for you. So the first thing to do is I want to get y prime. And what's that going to be? Well, I'm going to say, the derivative of x is 1. So e to the minus 7x squared. And then what are you going to get? Plus x times, well, that's easy. That's e to the minus 7x squared. And then the derivative of minus 7x squared is minus 14x. If someone says, this is so much work, I don't know if I want to do that work. I just want to point at things. Pointing at things is really not going to get you far. All right? You have to be able to do something. So I'm looking at this thing and I'm going to say, I'm going to factor out e to the minus 7x squared. And what do you get? You would get 1 minus 14x squared. All right. Now, by the way, I want to give you some line of encouragement over here. You should look at this and look at this and say, oh my God, I got the right thing. All right. Now, what is this giving us? And I want to point out what it's given me. It's given me information about, increasing and decreasing relative mins, relative maxes. Let's take a look at that. All right. So I'll put my little number line down. Whoops, sorry about that. Did it again. And again, we're not trying to encourage exhaustion, but some students are exhausted with the littlest amount of work. You got to improve in that regard. Now, where does this become 0? At plus or minus? Well, boy, asking me a tough one, right? It looks like 1 over root 14. All right, we're going to take some test values here. A good test value to pick would be 0. It's right dead center. If you plug that in, definitely positive. Now I want to take a number after 1 over root 14, and that's can be pretty nasty, but like a number like 1, definitely to the right of that. And if you plug that in, what would you get? Negative, decreasing. This is a max. All right, let's go below minus 114. I don't know, like maybe minus, I don't know, maybe minus 1. Plug it in. What do you get? Negative. Again, you would have to have some arithmetic skills to be able to do that. What's this over here? It's a minimum. So what I found, I'm going to write this down for you. I'm going to put this right over here. This is a relative maximum. I know this is difficult. We're trying to encourage it. What do you mean meet the difficulty? F of 1 over root 14. It's nasty. This is a relative minimum. And where did that occur? Minus 1 over root 14, comma f minus 1 over root 14. Look at the key later. Now what I got to do? I got to do second derivative. It's really nightmarish, but let's write it down so we can do it. So y double prime. Well, I'm going to do e to the minus 7x squared times root of 1 minus 14x squared, which is going to be minus 28x. Oh boy, it's going to be tough. Plus 1 minus 14x squared times the derivative of e to the minus 7x squared, which is e to the minus 7x squared. Whoops. I got a little touchy there, didn't I? 7x squared times minus 14x. I got to clean that up. It's of no use to me. So I'm going to factor out. Let's see what I'm going to factor out. I'm going to factor out minus 14x. I'm going to factor out e to the minus 7x squared. And then what do I get? I would get 2 plus 1 minus 14x squared. Don't despair yet. I think I did okay. We'll look at the key too, by the way, because mistakes happen. That's what's nice about having a key. It's nice if you use it, by the way. This is going to be 3 minus 14x squared. Right. I want to look back over the key. Certainly, and someone says, why do you do that? I'm encouraging you to do that. Right. I'm encouraging you to do that. I'm the one who wrote the key, by the way. So minus 14x e to the minus 7x squared. Wow, we got that right. So what I'm going to do, I want to, do that, basic, looking for points where it's, 0 and undefined and all that kind of stuff, right? So 0. And then I'm going to get 2 other points. That's the root. That's going to be, let's see, 3 over 14, but the root of it, and minus root 3 over 14 and the root of it. I know these are nasty. There's no doubt about it that these things are nasty. Someone says, I don't like those nasty numbers you give me. But we do give you pictures. Hopefully the picture's going to help you. Now I'm going to play it easy. I'm going to take a number that's clearly to the right of root 3/14. And what would that number be? Like 1. Plug it in. What do you get? Let's see, negative, and another negative, positive. Let me see if I did that right. 1 would be negative. Well, I'm sorry, negative times negative is negative. Let me make sure I did that right. So 1 I said, right? Minus 14, and 3 minus 14. Write that down. I'm a little tired here. So minus, plug in 1 there. That's the first fact. By the way, I'm looking at this. And the other guy was 1 minus 14, still negative. So it's positive. What does that mean? Increasing. You know what? I think I made a mistake somewhere. Oh, I'm sorry. I'm not looking at the first derivative. I'm looking at the second derivative. And I'm thinking, I was looking at the first derivative. I forgot what I was doing. And I'm glad I'm looking at a picture too, because I said, geez, that doesn't make any sense at all. So that's not, doesn't mean it's increasing. It means it's, let me get my eraser out. Erase this over here. It means it's concave up. All right. I'm going to make a number below minus 3 root 14, and the number I'm going to pick is minus 1. And if I plug in minus 1, I get positive. Again, we're still doing that factor analysis. And then minus 1 would be negative. So I'm going to say it's negative over here. What does that mean? Concave down. Now, granted, I know these are trouble. They're really troublesome numbers. I play it really safe. Like, like minus 1 over, I don't know, 1,000. And that would be over here somewhere. And then I try maybe 1 over 1,000, give me a number over here somewhere. All right, let's take a look. Let's do the 1 over 1,000 first. And what do you get? Well, again, I'm looking at factor analysis, looking at this guy, then this guy over here. What would you get? Let me erase this little stuff over here. So you get, the first factor would be what? 1 over 1,000. That'd be negative, right? What would the second factor be? Well, let's see, 3 minus incredibly small number. It's positive. So what does that give me? It gives me negative. What does that mean? Concave down. Let's do minus 1 over 1,000. And what would that give me? Well, again, I'm doing the first factor. I'm doing this guy over here. That's going to give me positive. And the second guy is going to give me positive as well. Again, I'm looking at factor analysis. That's something learned in math 119. So I have some points of inflection. I'll write them down for you. And the points of inflection, this will be a POI. This will be a POI. And this will be a POI. Let me go back to my graph. And I'm glad they gave me the graph. And I want to see if I did a good job on it. And what I mean by that, I'm going to point at you now. Concave down to that point. Then it goes concave up. I'm looking at my analysis, concave down, concave up. This looks good for me. And let's put these points of inflections in now, okay? And let me write them down for you. So this here, this is a POI. It's 0, F is 0. By the way, I know F is 0 is 0, but I'm still writing down F is 0. This is also a POI. And what's that going to be? Let me just make sure. Yep, root of 3/14, and then F of root 3/14. All right. What's this thing over here? Point of inflection. And that's going to be minus the root of 3/14, comma, F of minus root 3/14. All right, let's take a look and let's see if we've done it. All right, so local maximum at 1 over root 14, I have that written down. Local minimum at minus 1 root 14, I have that written down. Inflection points at 0, I have that written down, and plus or minus the root of 3/14, and that's written down for you. Again, for a lot of students, it's a lot of work. Whoops, sorry about that. We're encouraging it though. We're encouraging you to do the work. This one over here, again, is given the graph transition points. Well, again, I'm seeing it. I'm seeing a point over here. It's looking at its relative minimum. It also looks global. Relative maximum also looks global. I'm going to say it looks like points of inflection. Let me see. Concave up, concave down, concave up, concave down. Oh, geez, it'll be a lot of work, isn't it? Let's go through it. I think I'm getting a little better at this. So let's write down y prime. And what's that going to be? Well, the derivative of the first function, it's easy, right? 6x times the second function, e to the minus x squared, plus the first function, 3x squared minus 1. We'll check the key later. Times the derivative of the second, which is e to the minus x squared times minus 2x. I'm going to factor this, and I'm going to factor out, let's see, I'm going to factor out an x, and I'm going to factor out e to the minus x squared. And what do you get there? You're going to get 6 minus 2, 3x squared minus 1. Yep, you need algebra skills. This is x, e to the minus x squared. And this would be what? 6 plus 2, which is 8, minus 3x squared. Mistakes happen all the time, by the way. So what I want to encourage you over here, did I get the derivative right? And I think I got it wrong. And let's see why I got it wrong. I must have made some error somewhere. So let's take a look at it again. Did I do it right? So 6x, I got that right. I'm looking at line by line now. I'm looking at this, I got that right. Let me see, 3x squared minus 1, I got that right. E to the minus x squared minus 2x. Maybe I factored it wrong. I factored out an x, and I factored out e to the minus x squared. So would I be left off with 6 minus 2? I definitely see that. And then 3x squared minus 1. I'm still wondering what went wrong there. Don't see it, but I got to do it. I have to look again. I can't just accept that and say it's okay. It's not okay. So let's see if I did that derivative to get it right. So 6x, 2 times 3 is 6, x. And then e to the minus x squared, I got that, plus 3x squared minus 1, e to the minus x squared minus 2x. Let's go through that again. Oh, I think I see it now. X e to the minus x, 6 minus 2, e to the minus x came out, minus 1. Ah, I see it. I see it. Let me put this down over here. I'm glad I see it. 2 times 3 is 6. All right, there's my error. Let's keep going. They factor another 2 out. They get 2x e to the minus x squared. That would be 4 minus 3x squared. All right. Now I realize what some interested in saying, well, if I were like on exam and I was making mistakes like that, I don't know if I've made a mistake because there's no answer key over there. This is the whole point for practice and having a key in front of you. Let's see if we got that right. So I got this one. Let's see, 2x e to the minus x squared. Yeah, it looks good. So I'm going to put my little line down, my derivative, and at 0, certainly there. And the other place where it's going to be 0 is at, let's see what that'd be. That would be 2 over root 3 and minus 2 over root 3. All right, let's take some test points here. The number after 2 root 3 would be like, I don't know, 10. Plug it in, it would be negative. That means it's decreasing. I'm going to take a number like minus 10, plug it in. What would you get? Let's see. You get negative times a negative, which is a positive, which means it's increasing. Again, I'm using sign analysis. I'm looking at this, and I'm looking at this to do the sign analysis. Those two big factors, so to speak. Now, the other ones are more difficult. I'm going to take like minus, I'm sorry, 1/100th. And if I plug that in, what would you get? Positive for the first factor, positive second factor, positive, which means it's increasing. And then what do I get over here? I would take minus 1/100th because it's an easy number for me. That's going to be negative, and then I'm going to get positive, negative. So I'm going to write this down now. I'm going to say relative max at the point minus 2 over root 3, f of minus 2 over root 3, and a relative min at 0, f of 0. That's not so bad. and another relative maximum at 2 over root 3 f 2 over root 3. All right. So I'm going to say, I'm just going to look at the k, and I see that, and a minimum at 0. I definitely see that. All right, here comes the killer. The killer is, I got to get that second derivative. So I'm going to rewrite my first derivative, and I will check it. I'm going to make sure you understand what I mean by that. I'm going to write this as 2 e to the minus x squared. I'm going to bring the x and make it a polynomial, 4x minus 3x cubed. All right, it's going to be tough. Let's write this down. What's y double prime? Well, I'm going to just simply say the first function times the derivative of the second function. That's going to be 9, right? Plus 4x minus 3x cubed times the derivative of 2e to the minus x squared, which is 2e to the minus x squared times, ooh, it's going to get really difficult, minus 2x. I got to factor it. So I'm going to factor out, let's see what I'm going to factor out. A 2 and e to the minus x squared. I got to be really careful now. And again, if I get understand an exam, you get exhausted. I can't do it. I can't do it. I can't do it. If you're at home though, and you're doing homework and say exhausted, you really have to slap yourself awake, right? You have plenty of time, right? You have plenty of time. You make yourself a cup of tea if you want, but you got to get this done. You got to practice. So what do you get over here? So I'm looking at the first term, right? I factored out 2. I factored e minus x squared. What am I left off with? 4 minus 9x squared. Then what do I get? Plus. Let's take a look at this. What do I get? 4x minus 3x cubed. Boy, that's a nightmare. And then what do you get? I factor out 2, minus 2x. All right, and we'll look at the key later. I'm going to show you that. I got to clean this guy up. And what do I see? I see 6x to the 4th power. Then I see minus 8x squared minus 9x squared is minus 17x squared plus 4. Mistakes happen. Remember, we made a mistake last time, right? Let's take a look. See if we got it. I got the 2. I got the e to the minus x squared. Wow, got it right. Miracle. So what do I got to do? This is the tough part. I got to find the zeros now. So I know this part's never 0. It's always a positive number, by the way. It's this thing. It's a 4th degree polynomial. So let's write this down. 6x4 minus 17x squared plus 4 equals 0. I'm going to write this as 6u squared minus 17u plus 4 equals 0. And I want to see if I can factor it. All right. And let's see if we can do that. Let's see, 6 and 4 would be 24. That's not going to be good. 3 and 4. I had quadratic form. Let's write this down. U equals the opposite of B, 17, plus or minus. The bottom is going to be twice the A, right? 12. It's going to get tough. B squared, 17 squared, right? 170. 10 times 17 is 170. 7 times 10 is 70. 7 times 7 is 49. 289. Boy, that's nightmarish, isn't it? Minus, let me get my eraser out. My baby arithmetic doesn't need to be seen by anyone. 4AC, right? So it's going to be 4 times 6 times 4. That's going to be 16 times 6, which can be 60 and 36 is 96. I'm going to make eraser out. We got a key. We're going to look at the key later. So it's going to be 289. Whoops, sorry about that. 289 minus 96 now. What's going to be 3? This will be 18. That's 9. And you get 193. Let's put this down. U equals 17 plus or minus the root of 193 all over 12. Wow, that's a nightmare. Now, of course, so this is what you do with the u squared is actually equal to x4, right? You get the idea? Or x squared would be u. I hope you get the idea. So what do you have here? X squared is equal to 17 plus or minus root 193 over 12. Wow, I got troubles here. I gotta write them down now, right? So x equals plus or minus, it's gonna be a nightmarish, isn't it? 17 plus or minus root 193 over 12. By the way, I really don't want to belabor the point too much, but this can get really tough. This is my second derivative. And I'm going to write those 4 values down now for you. All right. So what do we get here? What's the most negative number? It would be minus 17 plus root 193 over 12. What's the most positive number? Root 17 plus root 192 over 12. Now the numbers in the middle over here is going to be 2 of them. One is going to be minus the root of 17 minus root 193. Oops, that's 193 over 12. I know this looks pretty scratchy to you. Okay. Okay. So I'm not going to take test points. So why is that? I'm kind of looking at the picture, and I think I can do this just looking at the picture, provided I can trust the picture. What do I know? Concave up, concave down, look at the picture, concave up, concave down, concave up. These are all going to be points of inflection. All of them. They're all points of inflection. All right, concavity is changing. Let's see if we got it right, though. It's right over here. They're all points of inflection. All right. Did we get the right number, though? Did I put the right number down? 17 plus root 193 over 12. Good job. By the way, if you have a textbook, I don't think they write that number down. They might simplify a little bit. I wouldn't worry about that so much. All right. So let's do this one over here, indicate transition points. Let's go to the next page and we'll do the work on the next page. All right. And this is number 6, right? So let me write this work down for you. And it might even be easier problem, who knows? But I'm going to put down y prime is equal to 1 minus 2 over x squared plus 1 times 2x. That looks pretty good. I'm going to simplify this. I'll check the key later. The denominator x squared plus 1, numerator would be x squared plus 1 minus 4x. Did I do that right? Yep, I think so. Let me simplify a little bit more. And what do you get? X squared minus 4x plus 1 over x squared plus 1. I want to look at the key, though. And so why do you look at the key? We're trying to get you to look at the key. Did I get the right derivative? I did. So what am I going to do now? I'm going to take a look at that derivative and I'm going to analyze it. But I got the picture and I'm going to trust the guy who gave me the picture. I'm the one who did it. So I'll put y prime down and I'm looking at it. And there's only one place where this thing would be equal to 0. It's never undefined, by the way, is when x squared minus 4x plus 1 equals 0. Let me see if I can do that. Oops, sorry about that. And I'll look at the picture too. Well, I can't use my finger numbers to do that. So I'll use quadratic formula. X equals, kind of nasty, right? So twice a, which is 2, minus b, which is 4, plus or minus b squared, which is 16, minus 4 times 1, which is 4. So you get x equals 4, plus or minus the root of 12 over 2. X equals 4, plus or minus root of 12 would be 4 times 3. So 2 root 3 over 2. X equals 2 plus root 3 or minus root 3. So I'll put those things down for you. And again, I'm getting a little better at this, and I think you are too. Not by watching, by doing, by the way. Let's look at our picture. We're cheating a little bit. I'm going to say increasing, decreasing, increasing. I'm just looking at the picture. What's this over here? Let's see, relative max. What's this guy over here? Decreasing, increasing, relative min. And let's see if we did it right. I already checked the derivatives out. So we'll say local maximum at, yep, I got that. I'm seeing it. Relative minimum. Yep, we got that. Let's do the inflection point now. And again, it's nasty, but we got to get there. All right. So we're doing the second derivative now. And we look at the picture. I'm going to look at the picture too. So we'll put y double prime down now. And we got a key to check. So what's going to be, we're doing this guy over here, by the way, which is going to be, you know what? I'm going to do this one instead. I'm going to do that one instead. It's the same thing, by the way. And why is that? Derivative one is really simple. So it's going to be the opposite of this guy's derivative. Well, it's quotient rule. So it's going to be x squared plus 1. I'm doing this guy here now. It's easier for me. You do what's easier for you, though. Do not think that what I think is easy is what you want to do. You need to do your own thing. So the bottom comes to the top. Derivative top minus the top times rid of the bottom, which is 2x. Let's see if we can do that. I did it again. I touched another button. I shouldn't have touched. Sorry about that. And I lost track of what I was saying. 2x. Okay, let's do that. Oh, I got to do it. And it's work. Let's see. That's going to be minus 8x squared. So it's 8x squared. And then it's going to be minus 4x squared. And then it's going to be minus 4. Well, I got to keep doing that, right? So what do you get over here? You're going to get 4x squared minus 4 over x squared plus 1 squared. I'm going to factor that out, by the way. So it's 4. X squared minus 1 is going to be x plus 1, x minus 1 over x squared plus 1 squared. By the way, I make mistakes all the time. I just want to check my K and see what they got. And I think we got the same answer. Let me just check it. And I think I said the same thing, right? 4x plus 1, x minus 1, x squared plus 1 plus, yeah, looks pretty good. Yeah, looks good. All right, put my second derivative down. Much easier than the first derivative. It's going to be 0 at plus or minus 1. I think I can look at my picture and I'm going to say concave down, concave up. I'm looking at the picture, by the way. And then let's see. Okay, so concave, let me look at this picture. Concave down. At 1, it goes concave up. I'm sorry, I made a mistake. Let me just I have to go backwards. I made a mistake. And mistake was this. I made a mistake over here. So I said at minus 1 and at 1, again, I want to go back over here and make sure you know what we're talking about. And I said between minus 1 and 1, it was concave up. That is not correct. I got to revise my picture now. It's not correct, right? Not correct. And let me get my eraser out. And again, if you went back to the derivative, pretty simple to do. Sorry about this. I got to pull this around. My screen is starting to, you know what? My pencil is getting weak. So between minus 1 and 1, like put 0, what do you get? You get negative. And then if I took a number after 1, it's going to be positive. A number below minus 1, and you're going to get positive again. Sorry about that. I was just going so fast I couldn't think what I was doing. Also, the picture is hard to look at. So what do I know? Concave up here. This may be hard to detect, by the way, but this thing's concave up. Then it's going to be concave down and then concave up. Points of inflection occur plus or minus 1, and that's clearly indicated over here. All right, let's look at number 7 now. They gave me the graph. Before I do that, though, I want to quickly go through the derivatives over here, and then we'll talk about what the graph has given us as well. I don't think we really need a graph for this one over here. The domain of this problem over here, though, the domain is going to be all the real numbers except 0. All right, let's put the first derivative down, y prime. What's that going to be? 3. Let's see, that would be x to the minus 1 minus 1 over x squared. What's y double prime? Oh, by the way, let me make sure you understand what I mean by this. This is 3x plus x to the minus 1. That's why I said 3 minus x to the minus 2. All right, and this is going to be 3 minus x to the minus 2. What's second derivative going to be? 2x to the minus 3. And what do you get over there? 2 over x cubed. All right. So let's take a look at the first and second derivative pretty quickly. These are much easier to deal with. 0 must be removed from the number line every single time. It's not in the domain of the problem. For the first problem, when is it equal to 0? When you get plus or minus 1 over root 3. If you're struggling with arithmetic or algebra, please come by and we can go through that with you. Let's do some sign analysis on that. I'm sorry, this is minus and this is plus. Take a number like 1, plug it in. What do you get? 1 minus, yeah, positive. You know what? I put in the wrong line. I'm getting tired. Move my eraser around. You know what? I'll just do this. All right. Let's use secondary. It's much easier. To the right of 0, it's positive, which means it's concave up. To the left of 0, it's negative, which means it's concave down. We looked at this one over here. All right, let's do the first derivative, which is much more difficult for me. Take a number like 1, you plug it in, you would get positive, which means it's increasing. If you took a number below minus 1 over root 3, like minus 1, you plugged it in, it's going to be positive. We'll look at the picture later, okay? Between 0 and 1 over root 3, like 1 over a billion, that's definitely over there. What would you get? Negative number. And minus 1 over a billion, negative number. Make sure I said that right. Yeah, it looks pretty good. All right, let's look at the picture. I'll grab it for you. And what I mean by that, I'm going to grab this picture here. I'm going to copy it. And I'm going to paste it. Okay. So my concern about this over here is that the concavity of it. First, it was the easiest thing to do. And what am I saying over here? To the right of 0, it's concave up. I'm definitely seeing that. To the left of 0, let me make sure I'm saying that. To the left of 0, it's over here, it's concave down. I'm definitely seeing that. Okay. Now let's look at the increasing, decreasing. 1 over root 3, right over here about, it's increasing. I see that. Now, between 0, it's decreasing. I see that. Let's see if it is over here. Decreasing, I see that. It's increasing over here. I see that. All right. What are these things over here? This is a relative. I'm saying that right. I'm sorry. I'm so tired. My picture, I'm putting these things in. It's not correct what I said there. I said decreasing, and I apologize for that. Thing like that. I'm sorry. Decreasing means going down. So this is relative max, which is anybody my graph. Over here, this is a relative min. Okay. There is no point of inflection, by the way, because 0 is not in the domain of the problem. So let's say if we got it right, relative maximum is at minus 1 over root 3, relative minimum 1 over root 3. Worked out pretty smoothly, by the way, right? And I think I did okay. Let me go to the next one. And again, we're learning by doing. What I would recommend you do over here is, the domain of it. I'm looking at the picture. It reminds me of what you've done in math 119. It's got asymptote at 0. And it's got an asymptote at 1. All right, looking at the picture, looks pretty simple. Transition points, looking at it, I'm not seeing any indication of relative mins or maxes on it or globals. I am seeing concavity, and I'm seeing that there might be one point on this curve where you'd get the concavity changing. By the way, a point on the curve, I'm not saying the concavity doesn't change, but let's go through the work. All right, and the work can be difficult. All right, so what I'm going to do over here is I'm going to rewrite it. I'm going to rewrite y, which is 3 over x plus 3 over x minus 1. I'm going to write it like this. And this might seem strange to you, but again, you decide how you want to do the work. I'm not always saying I'm doing the right thing. I just say this is what I feel like doing now. And what's y prime? Well, it's going to be minus 3 x to the minus 2. Well, it's just going to be minus 3 x minus 1 to the minus 2. I can write down y double prime too, really quickly too, by the way. What's going to be 6x to the minus 3? What's this going to be plus 6 x minus 1 to the minus 3. So that's not so bad. Let's do this now. Oh boy, I got a factor. And let's see if we can do that. And on this one, I'd factor out a minus 3. And what would we be left off with? 1 over x squared plus 1 over x minus 1 squared. That's done. Let's do this one over here. I'd factor out probably a 6. And what do you get there? 1 over x cubed plus 6 over x minus 1 cubed. I got that done. That's done. All right. Now, what do you know about this? All my analysis, every single thing in my analysis for these problems over here are going to be done on the domain of the problem. And the domain of these things is going to be, well, I can't include 0 and I can't include 1. So I have to remove those immediately. All right. Now the question is, looking at this over here, is this thing ever equal to 0? No, it's always negative, right? This thing's always going to be negative, decreasing, always negative, decreasing, always negative, decreasing. Let's look at the graph. The graph is always decreasing, always decreasing. I see that, by the way, on its domain. So let's do the next thing. This one's going to be a tough one. And I got to do this. So I got to figure out, is that thing ever equal to 0? Right? So let's over here, 1 over x cubed plus 6 over x minus 1 cubed. Does that ever equal 0? I don't know. I got to figure it out. So 1 over x cubed would equal minus 6 over x minus 1 cubed. X minus 1 cubed. Boy, this is going to get tough, isn't it? Minus 6x cubed. That's not so bad, actually. Oh, I got to go through the work though. I guess my studies from prior courses might help though, right? So I don't know. Let's just take the cube root of each side. Pretty easy to do that. X minus 1, cube root of 6, x. Boy, this can get tough, isn't it? 1. And 1 minus a cube root of 6, right? X. Let me see if I did that right. Yeah, I think so. So x will equal 1 over 1 minus the cube root of 6. All right, I guess that's point of inflection. All right, so, where is that number? It's over here somewhere. And I'm going to just look at it and just look at the curve over here. I'm going to say, concave down here. Again, I'm looking at it. I'm not really doing much work over there. After 1 is concave up. And this point over here, which is 1 over 1 minus a cube root of 6, it looks like concave up here. And then concave down here. Again, I'm looking at the picture. So I'm going to say there's only one thing I'm finding is a point of inflection. And where does that occur? And I'll check the key later. Okay, so let's take a look, see if we did it right. I made a mistake. I made a mistake. And I got to figure out why I made a mistake. Let's go back. And I made a mistake. So when you make a mistake, I say, one thing is you just go back over your work And maybe I should do that. Maybe I should look at my work and really an egregious error, say so to speak. Let's see if I did the derivative right. Let's see if I did that. I'm looking at it. Well, they didn't take the derivatives like I took them. So I'm not going to worry about that too much. I don't want to do over their work. I want to do over my work. So did I do it right? 3 over x is, let's write this down for you. This is 3x minus 1. I've already written that down, so I'm not going to write that down again. So 3x minus 1 plus 3x minus 1 to the minus 1. Did I get the first derivative right? So minus 3, x to the minus 2, and then minus 3, x minus 1 to minus 2. I did that. Good. I did it right. And then 6. Let's see, minus 3 times, 6, right? X minus 3, and then 6, x minus 1 cubed. I think I did it right. And let's see, 6, I pulled the 6 out, 1 over x cubed, 6 over x minus 1 cubed. I think I did it right. And then I got over here, and I guess I'm losing something over here, and I wonder what I lost on it. And I probably did something really stupid, didn't I? 1 over x cubed, 6 over x minus 1 cubed, minus 6x minus 1. Must have made a mistake somewhere. Minus 6, let's see. 6x minus 3, 6x minus 1 cubed. Again, I'm just looking at my work, a little tired, but I can do it. It's 3, right? 3 over x minus 1. 3x minus 1 minus 3 minus 2 minus 2. So that's 1. Let's go over a little bit. I see it now. I made a really stupid thing. I don't know how I did it and didn't see it like immediately, but I'm glad I looked back over it. And this is not 6 here. That's going to be a 1. And let me go back and erase. You know what? I'll erase the whole damn thing. I apologize. All right, let's write this down. What am I saying? 1 over x cubed plus 1 over x minus 1 cubed is equal to 0. I want to find 0. And we'll go back over it again. So it's 1 over x cubed equals minus 1 over x minus 1 cubed. Let me see, you get x minus 1 cubed equals minus x cubed. No, I don't want to cube it out. It's x minus 1 equals, the cube of that would be minus x. What do you get over here? 2x equals 1, or x equals a half. Well, it's actually a better number than we got before. So I got to erase this nonsense over here now. Let me do that for you. And again, this is the whole point of having a K, so you can look at it. We need to erase things that we make when we make mistakes, though. And that's a lot of students don't believe they need to do that. You need to get rid of things that are errors and improve upon it. All right, let's go over here. Let's put this down. All right, so second derivative, 0 and 1 are still removed because we're not in the domain of the problem, and a half is over here. All right, and again, just going back to the picture, point of inflection would be at a half. All right. All right, about a half somewhere. Maybe over here somewhere. What about, half. Let me see if that's true. Half. Yeah, it would actually be there. So let me just get my eraser out again. Really screwing up today, aren't I? So point of inflection is right over here. All right. And, concave down below the 0. It's concave up between 0 and a half, concave down between a half and 1, and then concave up afterwards. All right. So point of inflection. Let's go next page. And let's see if that half's written down. By the way, I notice my work over here is different. That's fine. You can do that work too. That's fine too. All right, let's do number 9. They got a picture for me again. The domain of this guy is pretty easy. My analysis is going to take place on the real number line, except at 0. So I got to put my derivative down. Should be easy. Let's see how many more problems we got to do. Yeah, 2 more to go. Let's see if we can do this. So y prime. Let me put y down first. That's going to be 1 minus 9 x to the minus 1 plus 3x to the minus 3. Y prime is going to be 9x to the minus 2 minus 9x to the minus 4. Y double prime is going to be minus 18 x to the minus 3. This will be plus 36 x to the minus 5. I'm going to scoot over a little bit. I'm going to factor these guys. A 9 would come out. I'm going to factor out x to the minus 4. And what he left off with, x squared minus 1. That's pretty simple. This guy, I'm going to factor out, let's see. I'm going to factor out a minus 18. And then I'm going to factor out x to the minus 5. And what would you get over there? X squared minus 2. Well, again, your mileage may vary, but I want to look at my derivatives and see if I've done that. And did I get this one right? Let's see, I got that right. Did I get the other one right? Yep. And I'm going to say analysis should be pretty easy. And again, I'm looking at the picture. Let's do the first derivative first. And I have to remove the 0. And it's at plus or minus 1. And what am I looking at? Well, not that I want to go through much analysis over here, but I'm seeing a relative max at 1. I'm seeing a relative minimum at, I'm sorry, that's minus 1. And this is going to be relative minimum at x equals 1. Let's just see if we got that right. Minimum at x equals 1 and a maximum at minus 1. All right, let's do the points of inflection, plus or minus root 2 and 0, but 0 is not in the picture. That would be a 0, by the way. By the way, this would also be, but it's not in the picture. And this one over here would be at plus or minus root 2. Let's take a look at that. So plus or minus root 2 would be inflection points. You know, you're looking over here somewhere, concave up, concave down, and then root 2 somewhere over here about, concave up, concave down. And that's also indicated. Let's go to the next one. I know I'm going through this quickly now. Again, you're more than welcome to come by during office hours if you need things done in a different way. Like you need slowness and you need more attention to detail. We're kind of roughly going through homework as I would do as if I were sitting in this classroom. I would also type it up though. My type work would look like the one you're seeing on the paper here, but I would do scratch work before I did any typing. So take a look at this one over here. And I'm looking at it, I'll write it over here. So it's going to be y equals, and I'd write this over here, x squared plus 2 to the minus 1/2. I'll take its derivative, should be fairly easy to do. Minus 1/2 x squared plus 2 to the minus 3/2, taking away 1, times 2x. And let's say indicate transition points. Well, I think I can do that. So y prime, 2's cancel, I get minus x. And then bottom, I'd get x squared plus 2 to the 3/2. Well, you know what? There's only one place that, by the way, depending on these things are all real numbers. There's only one place where it equals 0. So this is the place. This is the relative maximum here. Second derivative is going to be tough. Let me see if I got the first derivative right. Got it right over here. Let's do the next guy, which is the second derivative. And so why are you going to do that? I'm going to use the quotient rule. So square the bottom. So it's going to be x squared plus 2 cubed. Bring the bottom to the top and leave it alone. Times root of the top, which is minus 1, minus the top, times the derivative of the bottom, which is 3/2. Take away 1, that's 1/2. And then what do you get? Derivative of the inside's 2x, right? That's going to be a nightmare. Not really. I going to factor out x squared plus 2 to the 3/2. What do you get? -1. Let's see, plus, it's always tough for me, 3x squared. And then it's going to be x squared plus 2. Oh, no, x squared plus 2. Let's see, that'll be the first power. Let me see if that's true. It's always tough to do algebra, isn't it? So I get the first term, second one, the 2's cancel, I get 3x squared, and x squared plus 2, 3/2. No, that's not a good idea. Let me erase. I made a mistake there. Get my eraser out. Nice try, but it didn't work. I'm going to factor out x squared, I pencil back, plus 2 to the 1/2 power. Yeah, if something doesn't work, try again. What do you get? X squared plus 2 times -1. The next guy, you can get plus 2x squared. Let's see if I did that. No, I'm sorry, 3x squared. Yeah, I think I did it right. Let's get the key later. Y double primed. Let's see. I guess I could do some cancellations here, right? So it's going to be x squared plus 2. 3 minus 1/2. That's going to be 6/2, 5/2. And what do you get on top? Let's see. You get 3x squared minus x squared, 2x squared minus 2. Wow, that's working out too nice. What do you get over there? 2, x plus 1, x minus 1. And we'll check the key later. Let's take a look at that, see if we got that. And did I get that? Let's see, x squared plus 2 to the 5/2. I see that. I see the x squared minus 1. I seem to have an extra 2 left over somewhere. Which is not going to affect the analysis, but I'm wondering, where did I go wrong? Where did I go wrong? I got to look. X squared plus 2, I square that, I get that. And 3/2 minus 1 minus a minus x 3/2 x squared plus 2, 1/2 times 2x. I think I did okay there. Let me just keep looking through it. Maybe I have to change my key. Maybe I made a mistake. X squared plus 2 cubed. X squared plus 2 to the 1/2 power minus 1. Let's see. I say I'm missing a 2 over here. I'll check that later though. If I need to update my notes, I will. Okay, let's take a look though. What am I saying? A plus or minus 1 seems reasonable. I'm looking at this over here, and a plus or minus 1, I'm definitely seeing concavity changing. All right, so I'm going to say that looks pretty reasonable. I'm going to check, and you know what I want to do right now? I want to go to Sage for you. All right, so I'm going to switch screens. I know this goes not too long for some students. That's fine. You can always pause these tapes, come back to them later. So let me, I'm going to share a Sage screen with you, and just give me a second to do so. And someone says, well, if Sage can do all this stuff, why do you need to learn by hand? I think I should learn to do things by hand. So let me type this in, reset. See, we've done this many times before. X is a variable. You've seen me do this many, many times before. I'm going to define a function now. And the function I'm going to define is I'm going to define f of x. What's f of x? F of x is a function, and it's being assigned 1 divided by the square root of x squared plus 2. All right. And I'm going to do the first derivative. So I'm going to say df of x is equal to the derivative diff of f of x with respect to x. All right. I'm going to display that. Now, I'm not really questioning it so much, but I'm going to display it to show you how crazy things can look sometimes. But someone says, well, it's not that crazy. It's really the same answer you got over there. All right, it is the same answer. Now I'm going to make another function ddf, and that's going to be the derivative of df with respect to x. Let's see how we did over there. Oh, made a mistake somewhere. So, oh, you know what? I'm so sorry. I didn't do something. ddf of x is equal diff. Sorry about that. df of x with respect to x. I got this over. Let's just play it. I might have to correct my notes. All right, I'm going to do something here. I'm going to do bool. Boolean stands for Boolean algebra. And bool is going to return either it's true or it's false. So I'm going to say, is this thing here identical to what I said it was? And if you remember, I said it was 2 star x squared minus 1. I'm looking at my notes, by the way, that I just did in the whiteboard. X squared minus 1 star x squared plus 2 raised to the power minus 5 halves. It's true. My notes are error. So I got to correct it, and I will correct it, and you won't see that in your version of notes, but I just corrected, and it is true. But what I did, my derivative was correct. All right. So I missed a 2 there. I had to do that. I want to tell you another, silly anecdotal story. If you've paid attention this far, congratulations. But no one's ever brought that to my attention. And these notes have been used for over 10 years. All right. So what does it tell you? No one's looked at it. Or if they have looked at it, they didn't pay enough attention to it to know there's an error in the notes somewhere. All right. So that's important. If you do see an error, please bring it to my attention. Thank you so much.